Okay, Maria, I think we can start.
Yes.
Is that all right?
Yes, I will start to record it, and we can, yes, we can start.
All right. Thank you very much.
Thank you.
Okay, good morning. All is I'm Laura Martin. I'm coordinator of Research Project. I'm professor at the University of Cádiz in Spain. It's a pleasure for us to start today with this webinar, which is entitled Climate Change. As you know, the CU Talent webinars aim to disseminate the research of junior researchers of our CU Alliance. Today, as I told you, we are going to talk about climate change. We have two participants coming from the University of Gdańsk. Two presenters that are going to talk about the research that they are doing and about a special project, and a special AIDS 2020 project in which is involved this research and the results that they are going to present. So we have today two researchers from the coastal city Living Lab in Poland. We have Katarzyna Baranczuk, who is assistant at the Coastal Living Lab in Poland. And we have also to Hani Farhad Abd El Hanid, who is a scientific partner of the Coastal Living Lab in Poland, and is also professor at the Environmental Engineering and Technical University of Košice. They are going, as I let you know before, they are going to talk to us about the AIDS 2020 project called SCORE, Smart Control of the Climate Resilience in European Coastal Cities. This project involves different institutions that goes from universities to local administrators to different companies, and is creating a network of 10 coastal city living labs. It's a pleasure for me and for us to introduce both of them. Katarzyna is going to present, to make a resume of this nice project, and Hani is going to provide us the main results of this project, with the talk entitled Climate Change in the Context of a Historical Trend Analysis and Forecasting the Shoreline Changes at the Nile Delta using Digital Shoreline Analysis System. So I'm going to give the floor to both of them, to Katarzyna first to talk about the project, and to Hani to talk about the research that is being performed in the framework of this AIDS 2020 project. So the floor is yours. Thank you very much, and let's enjoy.
Thank you, Maria. Good morning. My name is Katarzyna Baranczuk, and I would like to briefly introduce the Smart Control of the Climate Resilience in European Coastal Cities project, acronym SCORE, which is funded by Horizon 2020. With my colleagues from the Technical University of Košice in Slovakia, Professor Martina Zelenakowa and Professor Hani Abd El Hamid, and with Jacek Baranczuk from the University of Gdańsk. We create Gdańsk Coastal City Living Lab. Our Living Lab is an innovative hub which coordinates the different activities of various city actors, different types of stakeholders, citizens, officials, business representatives, scientists, to address the specific climate challenges, for instance, rising sea level, coastal erosion, and extreme events. Gdańsk has got two key climate change hazards: pluvial flooding caused by torrential rain, and coastal flooding, storm floods, backwater, and ice jams. Our SCORE project is led by Dr. Salem Garbia from Atlantic Technological University in Sligo in Ireland. It consists of 10 pilot coastal city living clubs, which are located in Ireland, Sligo, Dublin, in Poland, Gdańsk, in Slovenia, Piran, in Turkey, Samsun, in Italy, Massa, in Spain, Villanova, Benidorm, and Basque Country, and in Portugal, Oeiras. The international consortium, over 170 people, works in 10 work packages. There are three main living clubs called front runners. They come from Benidorm, Barcelona, and Massa, and are our guiders for the whole project, for the methodology of the whole project. This figure shows the whole idea of the SCORE. It focuses on analyzing and monitoring water and climate hazards in 10 coastal city living clubs: coastal flooding, land flooding, coastal erosion, coastal storm surge. And it tries to find ecosystem-based approaches, which are supported by smart technologies and digital platforms. For instance, digital twin solutions, the SCORE ICT platform, low-cost sensing technologies for citizen science, and GIS early warning support platform. These mentioned three pillars are glued with living lab methodology, which focuses on participatory engagement in co-creation, implementation, testing, and evaluation of ecosystem-based approaches, and smart technologies to address climate change and resilience issues in coastal cities. Our case study is based on testing nature-based solutions with participatory engagement with citizen scientists and other stakeholders. And our Gdańsk CCLL has got different activities and is focused on mapping stakeholders, finding barriers and opportunities for solving problems with climate adaptation, analyzing past extreme events and hazard predictions, analyzing, exploring existing and potential ecosystem-based approaches, preparing multi-criteria analysis, deploying low-cost sensors suitable for citizen science activities, supporting and developing SCORE ICT platform for stakeholders to use different types of data informations models concerned with climate change, disseminating of risk assessment for policymakers. Thank you very much for you. Now I would like to introduce and invite my friend Hani, who will present the results of our work entitled Climate Change in the Context of Historical Trend Analysis and Forecasting the Shoreline Changes at Nile Delta using RS data and GIS with DASAS tool. Hani, please, the floor is yours.
Thank you, Katerina. Please stop share.
Yeah, please.
Do you see my screen now? Hello?
Yes,
Do you
we can
hear-
see it. Yes.
Do you hear me?
Yes, we can hear you.
Oh, okay. Good morning, everybody. First, I'd like to thank Maria and her colleagues for inviting me for this webinar. And thanks to my colleagues in Gdansk University for preparing such webinar. I'm Professor Hani Abdelhamid. I'm mainly from Egypt, but working as a fellow professor in the Technical University of Koshitsi. I am Professor of Water Resources Engineering, and I am interested in climate change and the impacts on water resources and coastal area. Today, I'm going to present just one case of our studies that we are doing related to climate change impacts on water resources and the coastal area. This case is how to detect the shoreline changes in the coastal area with a case study of the Nile Delta of Egypt using different tools like remote sensing, GIS, and the DASAS tool. In the presentation today, I am going to cover, I'll not go in more details or more specific details because I know, as Maria and my colleagues told me, the background of audience is different from students to researchers to scientists. So in this presentation today, I'll give a quick introduction to climate change, what is the main causes of climate change, how it will affect the different sectors. Then we will go to our case study on the Nile Delta, and we'll describe the study area, methodology, results, and we'll give the conclusion of the results and the references. But as I mentioned, it is just one case study. We have many research on the impacts of climate change and coastal area and coastal cities, flooding, and so on. First, as you know, that climate change refers to the changes in measures of climate for long period of time, such as changes in temperature, precipitation, and wind pattern. Actually, all of us notice now how climate change is affecting our lives. But if no action is taken to these changes, the world may affect more impacts in the future. So adaptation measures, mitigation to climate change is very important to tackle the challenges or the climate change consequences. This is just a brief introduction, definition of climate change. It will affect our life. So we have to work, we have to detect the impacts on different sectors. And how can we put adaptation and mitigation scenarios for this challenge? Actually, there are many running projects around Europe for climate change impacts and adaptations. We will present some of them during our presentation. Now, what are the main causes of climate change? As you know, it is maybe natural, due to natural processes like volcanoes, sun, or energy, but the dangerous cause is human activity. Now we believe that human activities are contributing to climate change in high level. For example, burning fossil fuels, deforestation, urban development, all of this increase the carbon dioxide emission, and this is cause global warming and cause the changes that we are suffering. Actually, we can't control the natural process, but we can control our activities. We can decrease these activities and protect the environment and protect ourselves. So what does global warming mean? Global warming mean is the increase in temperature, increase near the Earth's surface and in the lowest layer of the atmosphere. The global warming is the main cause of a climate change. How it is occurs? It is occurs to greenhouse gases emission from different sources. We have 4 main greenhouse gas emission: carbon dioxide, methane, nitrous oxide, and fluorinated gases. So these gases make light envelope around the Earth that allow solar radiation to penetrate into the Earth and prevent it going back. This increases the temperature around the Earth, which is called global warming, and which is the main cause of climate change patterns that we suffer from now. So, what is the impacts of increasing greenhouse gases emission and global warming? First, we notice increase in the global average temperature, and it is expected by the end of the century, it will increase between 1.45 degrees up to 4.8 degrees. This will have a great effect. Also changing in a precipitation pattern, which causes drought in some areas like Middle East and Africa, and some floods in some areas. Also reducing ice snow cover and increase oceans acidity and sea level rise, which cause coastal erosion and flooding in some area. Also, seawater intrusion in coastal aquifers is another problem. So increasing greenhouse gases and global warming should have many impacts, but increasing the global temperature and the consequences of increasing the temperature and severe and extreme events that we are noticing now, floods, droughts, wildfire, and so on, are related to global warming and increasing greenhouse gases emission. Now, climate change is affecting all the sectors: agriculture, coasts, ecosystem, energy, forests, human health, society, transportation, and water resources. These sectors are extremely affected by climate change. There are many research and projects are running for such impacts of climate change on these sectors and how can we adapt. But now today we are focusing on coastal area, and others may be in another webinars. By the end, all of these impacts affects the economy of nations, because climate change impacts adaptation, mitigation, voting solutions, all of these affect the economy and the society and the environment. Now we are going to explain very quickly the impacts of climate change on coastal area. Climate change could have impacts on on coastal area because rising temperature lead to melting more ice caps and glaciers, which rise the sea level, the global sea level, and cause coastal erosion and coastal flooding. Also, land subsidence in coastal area, it is probable to happen. It causes a change in storm surge frequency and increase precipitation intensity in coastal area. Also, rising ocean temperature will affect the coastal ecosystems. Coastal area is like any area. It is affected by climate change in addition to the impacts of it's close to the sea. Sea level rise will affect this area in addition to other impacts of climate change. Now, this is the last slide in the introduction, how climate change has affected Europe in the past 2 centuries. As we noticed this year, in the last decades, North Europe are getting more wetter and floods become common in this area. But in the southern and central Europe, they are getting more frequent heat waves and forest fires and drought. But the most affected area in Europe is the Mediterranean area, which is becoming drier and become more vulnerable to drought and wildfire. So the impact of climate change is a change on Europe from north to south to the central. And continue the climate change could lead to 400,000 annual deaths per year due to air pollution, only from Europe, 90,000 deaths as a result of heat waves, 40% losses of available water resources, fresh water, 2.2 million people in coastal area will be affected by coastal erosion and flooding, and about 100 billion euro annual economic losses. So the losses are huge. So scientists and researchers have to work how to adapt and mitigate with the climate change. How can we prevent or decrease our greenhouse gases emission to protect the environment and slow down the climate change. Now we will move to this case study. Why we selected this case study? It is one of the biggest delta all over the world. It covers an area of 25,000 kilometers square. This area, it is in the Mediterranean Sea in the north of Egypt. The coastline length is about 240 kilometers, and the depth between Cairo and the Mediterranean Sea is around 160 kilometers. Around 40 million people are living in this area. It is very, very condensed area, and the population growth rate is very high. So how climate change and sea level rise will affect the Nile Delta? It is like any other delta all over the world, but this delta is characterized by high population density and low-lying or low-level of land. So it will be extremely affected by climate change and sea level rise. So what is the impact of climate change and sea level rise on this delta specifically, Nile Delta of Egypt? First, coastal erosion, coastal flooding, land subsidence, inundation, seawater erosion, soil and ground salinization, evaporation increase because this is an agriculture area. Crude water demand increase due to increasing the evapotranspiration, shortage of water, fresh water resources, losses of agriculture land. It will affect tourism and others. So in 2002, the World Bank published these three maps for the shoreline of the Nile Delta. So this is the current situation in 2002, but due to increasing the sea level by 0.5 meter, which is expected, one of the scenario, this area, which in blue, will be submerged or will be flooded by the sea. And the worst scenario, if the sea level rise reach 1 meter, so this blue area will be submerged. Around 1/3 of the Nile Delta will be submerged by flooding from the sea or by the sea level rise, which will affect a large area of agriculture area. Many people will be affected, tourism and other sectors. So protection of such area is very important. Also, saltwater intrusion from the sea to the coastal aquifer in the Nile Delta is another problem. What are the aims of the current study? As we mentioned before, that climate change will affect the coastal area, and increasing the sea level rise as expected increase in sea level rise between 0.2 and 0.88 centimeter, 0.88 meter at the end of the century could have extreme effects on coastal area, as it could affect economy, building, roads, railways, and airport and ports. But the Nile Delta in Egypt, as I mentioned, will be extremely affected. So this study is quite important to detect and monitor the changes in the shoreline, how the shoreline has changed in the past, and predict the changes for the next and 20 years, and put integrated coastal management plan to adapt for these changes in this region. So monitoring the changes in the past will allow us to predict what may happen in the future in the next 10 and 20 years, and will give us the opportunity to put management plan to protect this area and to protect people's roads, economy, and railway and others. For this, in this study, we used remote sensing with GIS for collecting data, analyzing, and monitoring the changes. But DSAS, the Digital Shoreline Analysis System, is an important tool that can be used to monitor the changes in the shoreline and forecasting for 10 and 20 years. Based on remote sensing and GIS data for 50 years from 1973 to 2022 in the Nile Delta, we can analyze or monitor the changes that happened in the past 50 years and predict what will happen in the next 10 and 20 years. Why we use this tool? This tool is in this study. This tool is a free tool in GIS, and it is a productive tool for monitoring the shoreline change, mapping the historical changes in the shoreline, assessing the trends in the shoreline, and the predictions of future of changes in the shoreline, and evaluating the time series of changes in shoreline in certain places. For example, here, using this tool at different satellite images, we can monitor what is the changes happen in the shoreline. Is it moving towards the land or towards the sea? What is the rate of changes? And what may happen after 10 and 20 years? So this tool as a tool in GIS is a quite important tool for analyzing shoreline changes. This is the methodology we used in this study, and it is divided into 4 steps. In the first step is the data collection for 6 periods from 1974 to 2022. We have 6 different periods. We collected satellite images from Landsat with 30-meter resolution, which is free from USGS. And we started analysis for these 6 satellite images by first, the second step after the data collection is the data processing, because no one image cover all the delta because it is 25,000 kilometers. We have many satellite images. We used mosaicing methodology to combine these images together. Then we started mapping and forecasting uses this tool to monitor the changes between the 6 periods in the shoreline and predict the shoreline changes after 10 and 20 years. The last step is data presentation. We can present our results in maps, tables, graphs, photographs, and reports. This is for the methodology after we introduced the case study or the study area. This is the methodology and the tools that we used in this area. Now we will go for some results of this study. First, the historical trend analysis of the Nile Delta shoreline for the period 1974-2022, around 50 years. What we did, after we did mosaic, we compare the shoreline between the 6 periods. So the shoreline was here like this in 1974. Then the shoreline has changed in 1980. Then in 1990 and 2015 and 2022. Unfortunately, the changes here is not clear because the area is huge. So now we will try to take some sections or transects to show the changes in the shoreline in the 6th period. Also, these tools are used for prediction of the shoreline in the next 10 and 20 years because we did analysis for the 50 years from 1974 until 2022. We need to predict the shoreline after 10 years in 2033 and 20 years in 2043 to know what is the trends of the shoreline. Is it still moving inland or stopped or increasing? This is what we did. As I said, to make a more analysis of shoreline change in the Nile Delta between 1974 until 2022 and after 10 and 20 years, to make the results more clear. So this is our shoreline, and we took the 9 cross sections at the critical points, and the most area affected is the main 5 cities on the coast: Alexandria, Dumyata, Baltim, Rosetta, and Port Said. So you can see here the sections at Port Said, Dumyata, and the different sections and how the shoreline changed. I'll talk about only about 2 cases, is Rosetta and Port Said, because they are extremely affected by shoreline change. For example, for Dumyata, here this cross section, and Rosetta, because these parts are inside the sea. So if you look here, you can see how the shoreline changed between 1974 and 2043 after 10 and 2 years prediction. So the shoreline was here at the beginning at 1974. Then at 1980, it's moved inland, and the move is continuous, and the prediction also ensures that the shoreline will continue or the erosion will continue in this area. And then we can draw a time series of changing the shoreline at different transits. So once we draw the changes or the relation between the distance of erosion and the year, we can draw and we can get a relation or linear relation between the time and the changes in the shoreline, which can be used for prediction. Also, we did the same for all the cross sections, but as I mentioned, Dumyata and Rosetta are mostly affected. If you look at the left at Rosetta, also here we can see 2 transects, like the 2 transects here that we draw the profile here. You can see how much the shoreline changed from 1974 until 2022, and what are the prediction after 10 and 20 years. Also, the trends are increasing, and the erosion of the coastline is increasing and will have a severe impact. In this slide, we show the results of different parameters that we measure. We have 5 more for the statistical analysis of the parameters using this. We have 5 different parameters. What the 2 important are these 2: shoreline change in volume and the EPR, which represent how much change per year or endpoint rate. So for the shoreline change at the 9 cross sections that we selected, we can see here at Rosetta, for example, it has changed at 1 section. The shoreline moved inland around 2,655 meters, and so on for others. But EPR minus means erosion, and plus means accretion or movement of the shoreline towards the sea in the area which is protected. For example, at Rosetta, the shore EPR is around 54.69 meter per year. If this rate continuing, it will affect a lot this area. Also at Dumyata, the rate is high, but some others is low. So SCE and EPR are the most important parameters from this analysis that we used to protect or detect the shoreline change. Then we made a comparison between different sections, like 2 sections at Rosetta, 2 sections at Dumiata, 1 section at Manzala, to show how the shoreline changed at the same section at different years. The results showed that the maximum erosion occurred at Rosetta around 2,360 meters between 1974 until 2020, and it's expected increase, and the minimum occurred at Manzala. As you can see here, the change in the shoreline at Dumiata and Rosetta, which is a huge amount, as we can see from the table here, around 2,625 at one section and Rosetta, and Dumiata around 1,132 meters, and these are the rates of erosion per year. So the erosion rate is quite high. To conclude, this study gave us a good insight what has happened in the shoreline in this area in the past and what is going to happen in the future, which is a good indication, and it can be applied everywhere. To be honest, we apply this study in different areas in Egypt and some other countries, and we are going to apply these tools and these techniques in Gdańsk, in Poland as well. Finally, increasing climate change will have many effects on different sectors, especially coastal area will be extremely affected by climate change. The Nile Delta in Egypt, because it is below the mean sea level, it will be extremely affected by climate change and sea level rise. As we noticed in this study, that the shoreline has extremely changed in the studied time between 1974 and 2022, and will continue in the next 10 and 20 years. And these are the rates of erosion for some sections like Rosetta and Dumiata, between 30 to 60 meters per year at Rosetta, and 10 and 25 meters per year at Dumiata, and 10, 8 and 15 meters per year at Lake, which is high rate of erosion in this area. Continued erosion of the Nile Delta will have severe consequences on different sectors. It will affect ports in this area, buildings, roads, railway, people, and will affect the economy. So protection of such zone is very, very important and essential, but it is very, very costly. You can imagine how can we protect 240,000 kilometers, which is the length of the coastline over the delta. So we have to put a priority. We have to prepare like a risk plan, which area is with high risk, medium risk, and low risk. And this is what the government is trying to do now. I hope this case study give you just one example for one of the studies that we can do. How can we assess the impacts of climate change on some sectors, and how can we adapt with it? This, for more information about this case study, you can find our publication in Remote Sensing in 2023 and some others. Also, these are some references that we used in this presentation. Finally, thank you very much for your attention. And if you have any questions, I'm ready for answering. I think I tried to keep 25 minutes as I agreed with the organizing committee for my presentation. Thanks again.
Thank you very much, Hani. I would like to ask you one question. So you told it's very interesting presentation and your research. I have a questions relevant to these areas, which you told that they will be extremely affected by climate change in the Egypt.
Yeah.
Rosetta and Damietta, it's like will be drastically affected. And
Yes.
a very decent part of this area will be under the sea in the next years. And do you know if these studies was transmitted to the government of the Egypt, and if they are gonna to take some actions, preventive actions, to adapt to these changes.
Yes, sure. We already, it is already published in a scientific journal, and we have some meetings in Egypt, like COP27 last year that I should participate in, and such results are presented. Also, next week, we have a Cairo Water Week, which is an international event. It is related to the World Water Week, but it is focusing on Cairo Water Week. I'm going to present another case study. To be honest, I have a good relation with the government. I know the Minister of Water Resources and Irrigation in Egypt, and we are trying to pass such studies for them, just to keep eye on these hot spots and try to consider in the future. Actually, they are working already for protecting this area, and they have some plans, but we are trying to help them to show the hot spot, but protecting, as I mentioned, 240,000 kilometers is huge work to do, and it may take long time for protection, but they should have a priority. What is the important point to protect, and they have to start as soon as possible in this area. This is what we are trying to do as a researcher, to give more insight for these points. Okay?
Okay, thank you so much.
You
If
are
there
welcome.
are more questions, you can unmute yourself and make your questions. Looks like no one.
Maria,
Yes.
I would like first to thank Katarzyna and Hani for their presentations. I have some questions. I don't know to wait if anyone else would like to make a question, but as there is not anyone, maybe what we can do, Hani, is to stop sharing the presentation. Is
Okay.
that all right? Okay, now
Yes.
we can see our.
I thought the question may need me to go back to the presentation, so it is okay. Now I'm
Okay.
free.
Okay, thank you very much. Well,
Yeah.
very nice presentations, very complete. Thank you very much. It's very interesting, as Maria said, how, I mean, it's surprising that erosion at Rosetta is or could be from 30 to 60 meters per year. It's really surprising when we are talking about erosion or high level rise of, I don't know, 1 centimeter, 10 centimeters or something like that. When we talk, I mean, as far as I have heard about. So I think that is a very high range of meters erosion. And moreover, if we take into consideration that I didn't know that there is a population of 40 million people. I mean, it's quite high. It's very high, and I consider that it's I mean, it's a real. It should be a real objective for the government to start with for monitoring and actions to prevent any kind of adverse effects to population and activities. So I found it very interesting. I have couple of questions. One is regarding the project. What I found it very, very interesting all about the city labs. What are they doing exactly?
So this question may be for Kasia.
Yeah. Yeah.
I can answer, but Kasia can answer better than me.
Yeah. We are trying to collect different types of stakeholders from the cities and join together to create some different types of eco-based system solutions, which will help to prevent climate change. Our methodology is quite complex. However, it links different types of tools to enhance people to be active in the climate change and try to do something with this problem, and of course to share the knowledge about the climate change. We are trying to be some kind of hub which helps different types of people to solve different types of problems using many tools which are helping us to do it.
Okay, thank you so much. And another question, is it possible, there are 10 different living labs, 10 different networks, where it's only one network with 10 different living labs. Is it possible to take part of these living labs, although you don't belong to the project? Because as far as I know, I'm talking about the University of Cádiz and a little bit about the research that is being performed at the alliance level. And there are some researchers that would be very interested in participating in the project. Of course, funds are focused on the partners of the project, but maybe they can take part of this network. Do you think that this is possible? Are you giving this opportunity to other researchers from other institutions?
Yeah, we invite all interested people who would like to support us, and we would be very glad that other people would like to be a part of our labs. So for sure.
Because at the University of Cádiz, there are different researchers also doing research in how the shoreline, our shoreline in Cádiz in south Spain, is being affected by climate change. And they are studying flooding and shoreline changes. And they also have different citizen science projects. Cooperating with some researchers from Australia. So I don't know, maybe this could be an opportunity for collaboration in some topics. And the last question is regarding the cases of study. Which one? For example, today you have talked about the Nile Delta, but and it's really surprising how the predicted erosion of this area. Is there any other case of a study that is really surprising in the project? I'm talking, I don't know, are there other areas of high interest because of the results that are being obtained?
Actually, we have many case studies in the project, not only related to coastal erosion and coastal flooding. Also, the project include urban flooding and river flooding, and related to, as I said at the beginning, the impacts of climate change in European countries. So it includes different types of flood and different impacts. But they consider only 10 living lab in 10 coastal cities, but there are other partners from countries who doesn't have shorelines or coastlines, like Slovakia and some others. But we are participating in somehow for such studies, and we are using different models. If you go for the website of the project, you will find different case studies in Italy, in Spain, in Poland, and some others related to different topics of climate change, not only coastal erosion. So we have many case studies. They are using different models for different areas. So you can find, we may ask, or if you ask us, we can present how many case studies we have in different partner countries. This is just one example that we presented today because of the time allowed for us, only 20 or 30 minutes. So maybe next time we will prepare or account the number of case studies that we including in the project.
Okay. Yes, I saw that is also participating the University of Pisa and some other universities of Italy. Well, it's really interesting. And moreover, not only the research, but also what you are doing with the network of City Living Labs. What I mean, this is a good way for dissemination, communication, for engagement of stakeholders, for looking for responses and so on. There are some I can remember. I mean, now it comes to my mind. For example, cases like the city of Venice, or in Italy, or for example, different Miami or different cities of Florida.
Sorry, Maria. By the way, if you are interested, we are preparing a new proposal for a project in cost action about climate change. You can participate if you like.
Well, my topic of research is completely different. Well, although we are starting to, and my field of research is ecotoxicology and environmental monitoring, and it's true that we are starting to study the effect of temperature of warming in organisms, in invertebrate species, marine invertebrate species. It's not exactly a topic, but I have very close colleagues, researchers at our university, at the University of Cadiz, that they do research on this topic, and I think this could be a good opportunity to put them in contact with you. So let's see. So thank you so much. I don't know if there are more questions.
Yes, there is Cecil. He would like to make some comments.
Okay.
Hello, you can see me and hear me, I think. I'm one of the partners of, I'm representing one of the partners in the SCORE project. I'm actually from the Science and Research Center in Slovenia, in Koper. I could elaborate a little bit more what the SCORE project actually would like to do. It's not so much that all the coastal cities which are mentioned, the 10, are actually implementing ecosystem-based approaches. Some of them are, these are the front runners, and other ones will follow. And they are kind of having the same kind of co-creation approach. So they are gathering a lot of stakeholders to think about what are the hazards in their city and what kind could be the solutions. And they come to some kind of consent to implement, even if it's only on policy basis. So what could be suggested in the future for the city to adapt better to the specific climate hazards which are occurring in their city. So basically, we have a few cities which are way ahead in the project, and they are actually implementing in their study sites, indeed, ecosystem-based solutions. So that could be against, indeed, coastal flooding, that could also be against river flooding, that could be against drought and heat waves. So in a kind of way, it's very diverse, With 10 cities, you can imagine that there are many different kind of approaches, but they follow a similar kind of approach in that it's a co-creation. So the quadruple helix is represented in the decision process and in giving priority to what and thinking about what approaches, but ecosystem based, could be the best to implement in their particular geographical situation to adapt the city for climate change. Basically, that's basically their approach. So there's a lot of results coming out and a lot of deliverables which are being shared with anybody who is interested. And in that sense, there's also possibility eventually to give more detailed information about the methodology later on in the project as a guidance to other projects to pick it up and to go further. But as you understand, all kind of geo-reference sites are having a different situation, a different kind of stakeholders which are proactive, a different kind of political situation, but also financial situation. And this will all be taken into consideration also in the score. So eventually you get different results, but it follows a different kind of, a similar kind of methodology. And this is basically what we are hoping that will be disseminated and adapted and very clear. So actually there are better tools available to work with a large group of stakeholders in every kind of setting, not only in Europe, but even across the Mediterranean, also in the northern of Africa, indeed. So that's a little bit more of detail given it.
Thanks, Cecil. Okay. Actually, if we would like to talk about SCORE project, we need the whole webinar to explain what is the activities in SCORE project, what is the case studies, the partners. So maybe in another webinar. But the website include, as I mentioned, and Cecil mentioned, on the website, you can find more details. You can find whatever you want, case studies, partners, and methodologies. So it is a really good website and include a lot of data for public, which is for a project dissemination. Okay?
Yes, I agree. I also can mention that I'm from Maritime Academy in Lithuania and from Klaipėda University. And a long time I investigate how the port and city could join to the cluster to develop as one sustainable unit and increase in the coastal resilience. So now I'm in France, in Le Havre, and I had a presentation in an international conference, and now I work on cultural component which could increase in sustainability through the cooperation, strengthening the cooperation between ports and cities. And a lot of new knowledge I've got from this research, because I don't know how in your countries, but usually in our region, maybe Polish researchers agree with me, some green transition projects are going slow. They are implementing slower than other projects, and it is because, for example, in Lithuania, we have confrontation with citizens. They want to keep good environment for their living quality in the port areas, but they don't know to get new technologies in the port, because the wind farm will damage nice view on the sea, and a lot of different confrontations appear when we're talking about green transition. So in my research, the line is that we need to develop culture of citizens of societies to live without to change living conditions and living habits. And maybe we should also talk about the new general trainings and education, maybe, I don't know, maybe joint study program about the development of sustainable culture, a sustainable consuming culture, because without these cultural elements we cannot to improve and to increase in the developing of green projects and implement them because the society, citizens are not decided what we want to see in the future. So this is my new researches, and if you will be interested, I can join your researches also.
Thank you, Elena. Thank you very much. Good point. Culture. And reducing consumption and being, more sustainable, difficult issue. And it's, the thing is that we need to change, and it's difficult. Well, so any more questions?
I don't have any questions, but just I wanted to add that it's true that there are a lot of, in coastal management, there are a lot of conflicts because it's very busy areas, and there are presented a lot of businesses, seaports, tourism, and that's why there are a lot of conflicts. It's very good point that Elena raised, and I totally agree that a lot of people, they are against these infrastructures which are needed to protect the coastal area. That's why I think we need to increase this awareness of local citizens about the current problems to introduce it and to talk with local citizens and convince them to accept this needed changes. Yes. So I don't see anyone raised more hands or some comments in the chat. So Laura, would you like to add something more?
I would like to thank you again to the speakers and to the attendees, the people that listen to our presenters in such a nice topic and such a nice and interesting project. And I would like just to let you know that we can. We are there. You can have a look to our webpage. You can have a look to our social media information to know a little bit more about the project. We are almost finishing at the end of the project is finishing at the end of December. Everything will be in the framework of the CU Alliance. So you have more information, and we can try to open new bridges for collaboration on this topic. And that's all. I hope you have enjoyed, and we will see you in the next webinar. Thank you very much.
Okay, thank you so much, everyone. One more small thing which I would like to add. So first of all, to thank you to all speakers, all attendees, and we will provide all of you with a certificate of participants during this month. So thank you so much, and we can end. Have a nice day. Bye bye.
Thank you.